Okay, hey guys, so we're going to go ahead and go over day 2 notes today, binary ionic chemical names and formulas. So really quick, we're just going to go over a few things that should be just review for us. So what are atoms that have lost or gained one or more electrons? Well, those are called ions. Okay, so what are positively charged ions? Well, those are cations. Okay, remember what we always say when we have cations, they are positive because cats have paws, so they are positive. Okay, and then negatively charged ions are called anions. Okay, and I tell you guys that anions kind of sound like ants, and ants, when they bite you, well, that's a bad thing. They hurt, so it gives a negative connotation. So anions are negative. Okay, and then a charge on an ion is known as the oxidation number. Okay, so if you ever hear me say, what is the charge of an ion, or what is the oxidation number of an ion, it's the same thing. Okay, we wrote our oxidation numbers on our periodic tables yesterday. So if you take a look right here, okay, on our periodic table, those numbers above the groups, those are our oxidation numbers. Okay. And so, what is an ion consisting of 2 or more atoms? Well, that's called a polyatomic ion. Okay, so polyatomic ion. Okay, the prefix poly means many, atom, okay, many atoms. We have a polyatomic ion. Okay, so practice. This is practice from yesterday. So write the ion with the charge for the following elements. So lithium on our periodic table. Okay, so let's take a look at our periodic table. Okay, let me move my face over here. Okay, so on our periodic table, lithium is right here, and that is under group 1, so its oxidation number is +1. So our charge for lithium is going to be positive. Okay, beryllium is in group 2A, so its oxidation number is going to be a +2. So a charge 2, positive. I know some of my students have already asked me, Ms. Breeze, does it really matter where your charge goes? Well, rule of thumb, your charge always goes after the number. Okay, so again, your charge always goes after your number. Okay, so aluminum is in group 3A, so it's going to have a +3 charge. So 3 positive. Okay, and then sodium. Sodium is in group 1A, so its oxidation is going to be a +1, or its charge is going to be a +1. And then fluorine is in group 7A, so it's going to have an oxidation of -1. Okay, so -1 for fluorine. Okay, so at this time, go ahead and pause the video. I'm going to go ahead and give you guys some time to do the rest on your own. Practice and see if you can get the same oxidation numbers or charges of your ions if they are going to be correct. Okay, so at this time, go ahead and pause the video. Okay, so I hope you got the same answers that I did. Calcium, +2. Silicon, 4, positive or negative. Sulfur, -2. Francium, -1. Chlorine, -1. So on and so forth. Okay, so again, you can just pause the video if you need to check your answers, but I'm going to go ahead and move on. Okay, so that was just supposed to be a review from yesterday. Okay, so Ionic compounds. Okay, let me move this. Sorry. Okay, ionic compounds. Ionic compounds are made up of a metal and a nonmetal. Okay, or you can consider them as your cations and an anion. Okay, because remember, our metals are mainly going to be our cations, because on the periodic table, well, what kind of oxidation number do our metals have? They have a positive charge. Okay, so again, our metals are going to be our cations. And then our nonmetals, if you take a look, they are mainly negative. Okay, so they are our anions. Okay, so the bond involves the transfer Okay, hold on 1 second. I don't think that's the right word. Okay, I was just kidding. It was the right word. Okay, so the bond involves the transfer, okay, of electrons. The electron is transferred from the cation to the anion. Because remember, if we're dealing with cations, they are on this side of our periodic table. Okay, groups 1 and 2 are most likely going to give up their electrons compared to our nonmetals. Okay, so our cations again are going to transfer their electrons to our anions or our nonmetals. Okay, so that way they can both achieve a valence electron of 8. Okay, and your overall charge of your ionic compounds must equal 0. Okay, so basically what that means is that if we have sodium, which is a positive 1 charge, okay, and if we have chlorine, which is a negative 1 charge, our charges must equal 0. So positive 1 and negative 1 equal 0. They cancel each other out. Okay? Alright, we'll get more into that in just a second. Okay, so let's move on to naming ionic compounds. So when we name ionic compounds, first we name the cation, okay, or our metal. Okay, so remember our cations are our metals. Okay, and then we name the anion, okay, or our nonmetals. Okay, and then we're going to change the ending of our anion to IDE. Okay, so for example, if I had magnesium and I had chlorine, well, the name would be magnesium chloride. Okay, so that ending needs to be changed to IDE. Okay, so if we have lithium and sulfur, well, our name would then be lithium sulfide. Okay, so lithium sulfide. Okay, so if you wanted to go ahead and practice, go ahead and do the next 4 on your own. You can always pause the video and then push play. So at this time, if you want to go ahead and pause to do the practice on your own, please do. Okay, so to solve these, we have magnesium and we have oxygen. So the name of our compound would then be magnesium oxide. Okay, so magnesium oxide. Okay, notice how we changed the ending of oxygen to oxide. Okay, the next one, we have potassium and we have phosphorus. So that would be potassium phosphide. Okay, the next one we have cesium and chlorine, so the name would be cesium chloride. And then the last one, we have barium and nitrogen, so then that would be barium nitride. Okay? All right, so moving on to the next page. Okay, it's Lewis dot structures for ionic compounds. Okay, so again, the overall charge on the compound must equal 0. So that is the number of electrons lost by one atom must equal the number of electrons gained by another. Okay, so your Lewis dot structure of each ion is used to construct the Lewis structure or the electron dot diagram for the ionic compound. Okay, so the Lewis dot structure shows the location of the valence electrons after the electrons have been transferred. Okay, so this is what it's going to look like, your final product. It's after they have lost or gained electrons. Okay, so the example that we have here is lithium fluoride. So lithium, because it has a positive charge, it means it's going to lose one. It has one valence electron, so it's going to give that away to fluorine, who has 7. And it's going to gain that one electron, and it's because it gained that one electron, it's going to be a negatively charged atom. Okay, so this is how it's represented once they've given away their electrons and once they've taken their electrons. Okay, so let's go ahead and try this example with lithium oxide. Okay, so usually what you want to do is you want to go ahead and draw your nonmetal first. So I have oxygen. You don't necessarily have to draw your nonmetal first. You'll see why in just a second. Okay, so lithium has how many valence electrons? It only has 1. And then oxygen, as you can see, I've drawn 6 valence electrons, okay, or 6 Lewis dots to represent those 6 valence electrons. Okay, so how many more does oxygen need to complete its valence shell? Well, if it has 6 valence electrons and it wants 8, then that means I'm going to need 2 more electrons. Well, lithium only has 1 electron. Okay, and just like the seats on the bus, lithium doesn't want this electron anymore, so this electron is going to come over here and sit by this electron on the bus. Okay, and again, we have 1 more seat available, so what we're going to do is we're going to add another lithium. Okay, again, lithium has 1 valence electron that it's going to donate and give to oxygen. Okay, so now at this point, lithium is going to have no more electrons because they both donated those electrons to oxygen. Oxygen now has 8 valence electrons, and it has completed the octet rule. It has 8 valence electrons. Okay, so what would be, we have to now write our formula like this. Okay, so there's 2 different ways that you can do this. If you notice, we have 2 lithiums and 1 oxygen. So I have a lithium in brackets, okay, and then I have an oxygen in brackets, and then I have another lithium in brackets. Okay, so now we're going to go back to our Lewis structure drawing. Does lithium have any more electrons? No, right? Because we've given those away to oxygen. Okay, and how many valence electrons does oxygen have now? Well, it has 8 now because it's received electrons from lithium. Okay, so now we have to add our charges. Well, what's the oxidation number for lithium? Or the question you really should be asking is, how many electrons did lithium give up? It gave up 1. So if we're losing electrons, we're going to have a positive charge. Okay, oxygen, how many did oxygen gain? Oxygen gained 2 electrons. And then lithium, again, this lithium, it gave away 1 electron. Okay, so you can always draw your Lewis dot structure this way, or you can do it this way by adding a coefficient in front of lithium to let us know that, hey, I actually have 2 lithium ions, and both those ions have a positive charge because both of them had lost or given away an electron. Okay, and then next to that, you can draw your oxygen. Okay, and then oxygen, since you only had 1 oxygen, you don't really need a coefficient to represent that you had just 1. And then don't forget your negative sign. Okay, so on your homework, I should see this work right here. Okay, this is the type of work I expect y'all to see on your homework. Okay, so now, what would be the chemical formula for this compound? Well, let's take a look. Remember, when we write our chemical formula, your metal always goes first. Okay, and then your nonmetal. Non-metal. Okay, so metal plus our nonmetal first. Okay, so which one of these is your metal? Okay, it should be lithium. So lithium is our metal, and how many do we have? We have 2 lithiums, so that's going to be my subscript. And then our nonmetal is oxygen. So how many oxygens do we have? Well, we only have 1. Do we need to write a subscript 1 for oxygen? No. Okay, it's given. If there's no subscript, then that just means we only have 1 atom of that element. Okay? Alright, so now that you guys know how to draw Lewis dot structures for ionic compounds, and y'all know how to name ionic compounds as well, now we're going to write our chemical formulas. Okay, so when given 2 ions, you have to balance the charges and make them the subscripts. Okay, so you're balancing your charges and then you're making them subscripts. Okay, another rule, we do not keep our positive or negative signs when our charges become subscripts. Okay, so you are going to reduce your subscripts if possible. So meaning that you must reduce the subscripts if they have a common denominator. So in our example, we have calcium 4, fluorine 8. So we have 4 calciums and 8 fluorines. Well, 4 and 8 can be reduced into smaller numbers. Our common denominator for 4 and 8 would be 4. So 4 divided by 4 is 1. So calcium would then be 1. And fluorine, 8 divided by 4 would be 2. Okay, so when we reduce it, Ca4F8 is going to be reduced to CaF2. Okay? Alright, so there's 2 different methods to writing chemical formulas. Okay, so the first way is to use the balanced charges method. Okay, so the sum of your charges must equal 0. Okay, so if we take a look at example A, sodium positive 1, chlorine negative 1, well, our charges cancel each other out. It equals 0. So that means we would have just 1 of each element. Okay, same thing for magnesium and oxygen. Well, positive 2 plus negative 2, they cancel each other out to equal 0. So that means we would just have one of each element. Okay, remember, do not write magnesium 2, oxygen 2, because it must be reduced. If you reduce this by the common denominator 2, it'll be reduced to Mg and O. Okay, the other method, which I know a lot of my students find the easier way, is the crisscross method. What you're going to do is your subscripts are going to become, let me start over. Okay, what you're going to do is your charges are going to become the subscripts for the opposite element. Okay, so I'm going to go ahead and write that down. Subscripts become, oh, I did it again. I went backwards. Your charges. Your charges become the subscripts for the opposite element. Okay, so again, your lithium, your 1 from lithium is going to crisscross, and it's going to become the subscript for oxygen. Okay, and your charge for oxygen, your negative 2 charge, is now going to become a subscript for lithium. Okay, so let's go ahead and try a few examples. Okay, so lithium oxide, which one's going to be our cation, which one's going to be our anion? Well, remember, our cations are always the first one, and they are also the metals. So lithium is going to be our cation. So lithium, and we always want to include the charge. So lithium is going to have a positive 1 charge. Okay, our anion is then going to be oxygen with a negative 2 charge. But let's take a look. Okay, positive 1 does not balance out to negative 2. So what you're going to have to do is you're going to have to add another lithium ion. Okay, so now you have positive 2 and you have negative 2. So they cancel each other out now. So your formula, again, lithium, how many do we have? We have 2. And oxygen, we only have 1. Okay, so our formula is Li2O. Okay, let's try another one. Magnesium sulfide. So magnesium is going to be our cation, so Mg, with a charge of positive 2. And then sulfur has a charge of negative 2. So in this way, your charges are going to cancel out. So then your formula would then be MgS. Okay, and we also had another example on the PowerPoint. We didn't actually have magnesium sulfide, we had magnesium phosphide. Okay, so our cation for magnesium phosphide would actually be Mg, positive 2, and phosphide, our anion, would be phosphorus, negative 3. Okay, so we know that our charges are not the same. They are not balanced. Well, we have to think of our, you can either do it the balancing charges method or the crisscross method. Okay, personally, I like to use the crisscross method because, again, it is easier. So remember, our charges are going to become the subscripts for the opposite element. So the 2 in magnesium is going to become a subscript for phosphorus, and then the 3 for phosphorus is going to become a subscript for magnesium. Okay, so then our final formula would be Mg3 phosphorus 2. Okay? All right. So that is it for our notes for today. But I did want to go over just a few things from your homework. Please be careful with number 4, because remember, we always reduce our compounds if they can be reduced. Okay, if you leave it like this, Mg2O2, it's going to be wrong. Okay, and then just another reminder for your Lewis dot structures. I'm going to go ahead and do one with you. Okay, so sodium, how many sodium ions do we have? We have 2 sodium atoms, so 1 and 2. And then how many oxygens do we have? We only have 1. Okay, so how many valence electrons does sodium have? Sodium has 1 valence electron. Okay, so both of them are going to have 1 valence electron each. And then oxygen has 6 valence electrons. Okay, all right. So remember, with the Lewis dot structure for compounds, we have to show where our electrons are going. And remember, they're trying to get a seat on the bus because sodium doesn't want these electrons. Okay, so this electron is going to come over here and sit by this electron with oxygen. And then this electron is going to come over here and sit by this oxygen on the bus. Okay, so your final product, okay, you have sodium, okay, and you have oxygen. Okay, so again, we have how many valence electrons now? Well, sodium doesn't have any more because it's given them up to oxygen. Okay, so the oxidation number for sodium is positive. Oxygen has how many valence electrons now? Well, it has 8 now. Okay, it gained 2 more from the 2 sodiums. So if it's gained 2 more, well, it's going to have an oxidation number of -2. Okay, and then don't forget coefficients. How many sodiums did you have? I had 2 sodiums. And then how many oxygens did you have? Well, I only had 1. Okay, so this should be your final answer for your Lewis dot diagram structures. Okay, so if you have any questions, please let me know. I hope everything made sense. I hope you guys didn't get more confused after this. Okay, let me know if you have any questions.